Hello, in this tutorial, a terrain will be obtained from GeoGratis Canada, and it will be converted to a 3D mesh and saved to a Lightwave LWO file. This is a piece of the Columbia ice field that was already obtained from GeoGratis. It has 5.4 million triangles, and if I zoom out, we'll see that it's rectangular in shape, and we can move around and so forth. Now, I'll use the Edge web browser, since I'm on Windows 10, to go to the Natural Resources Canada website, which is at nrcan.gc.ca. Once you're there, you go to the Earth Sciences, click on Earth Sciences Resources, and then click on Earth Sciences Tools and Applications, which will bring up this long list, and we want Geospatial Data Extraction. And it's updating a map now. This can be quick or slow depending on how fast the server is responding at Natural Resources Canada. We have everything that we need for getting our terrain is located here, and we can zoom in and move around on the map with these controls, or we can click on it and drag and so forth. So we now have a map of Canada, and once that's up, we could take and click on View NTS Grid, and you'll see that Canada is divided into a whole bunch of grids with numbers on them. You can move in on the grids, and you will find out that each grid is filled with 16 more rectangles labeled from A to M. And if you zoom in on any of those rectangles, they will be broken down into another 16 rectangles with the numbers from 1 to 16 on them. Now, the easiest way to get where we want to go is just to type in a location, and I'm going to type in Mount Logan, and then press search, and we get a bunch of suggested locations. And I'm looking for Mount Logan in the Yukon, which is a mountain. So I'll select that one and click Display. And we've got controls here for moving around in the map. You can click on the map and drag with the mouse. You can zoom in and out with the mouse wheel. And it's really slow tonight. I've had better response in the middle of the day. So now we have a contour line showing the different heights and so forth around in the area. So now the first thing we have to do is select a clipping area, and the one is called Current Map Extent, and that will give us basically what we're seeing in this window here. It could be a little bit larger, a little bit smaller. It just varies to what they have set for any particular area on the map. The other, we could go to a predefined clipping area, and based on Landsat footprints and so forth. And I haven't played too much with this because the response is kind of slow, and you have to figure out what all the numbers are so you end up in the right place. So I'll go to the custom clipping area, which you'll probably use the most. We have enter coordinates, and if you know, based on latitude and longitude, the top northwest corner of the area you're interested in, and the bottom southeast corner, it's quickest to add the latitude and the longitude as decimal degrees than to scroll all over the map trying to find out where you're going. And return to the menu. Okay, otherwise we have two other areas. One is draw a rectangle, so I can select that, and then I can just say, okay, I want this area in here, so I can just click, and while holding down the left mouse button I can just draw out an area, and so now I have an area defined that I wanted to use. Or I could do a polygon, and I can click on the polygon. Instead I could say, okay, I want it to start here, and release them. Click the mouse once to start drawing, and then you come out and then click the mouse again, go down to another place. Okay, I want it there, I want to come up like so. Click the mouse once, move over, click the mouse, come down. Oh, yeah, I'll go over there, click and click, and then when you're finished you just double click, and now we have a new extent set up, and that's what we'll get when we ask for it. Then you go to the next step, is select data, and we have two choices for elevation data. We have surface model and elevation model, and if we click on the question marks when they appear, this will come up and it'll tell us a little bit about the surface model, and that we're going to get approximately 20 meter space distance between the sample points, and the data come from a radar mission that was done on the space shuttle. And this doesn't give us the best heights because we get building heights and tree heights and so forth included in the model. So the one you'll want to use the most probably is the elevation model, the CDEM, and you've got other things here that you can try for other things. You've got lots of selections. So now we have to say what kind of data we want, and you check whatever you want. If you check DEM, you will get a GeoTIFF file, which you could use with the free MicroDem program to investigate features around on the terrain. You can get shaded relief maps, color relief maps, and so forth. Now the one we want is point data, and that's going to give us a CSV file standing for comma separated value. Now if you're zoomed too far out on the map and there's just too much data, this will be grayed out, and you can't check on the box. So what you have to do then is zoom in until this finally isn't grayed out anymore, and then you can get it at that resolution. Now there are two types of projection. We have geographic, and it's got several different resolutions, all based on arc seconds. And so what happens here is you get the X and Y coordinates are in decimal degrees of latitude and longitude. And if we go here, we've got another choice. We've got Lambert conformal conic, and this is the best one to use because the GeoProjection got changed into a flat map, so we have meters for both the X, Y, and Z axis, and then we have different amounts of resolutions that we can get, and we get less and less points as we get a larger distance between the sample points. And the Lambert conformal conic projection looks like this. They project the world onto a cone and then spread out the cone, and this gets used for aeronautical charts. And in this wiki, there's quite a bit you can read about how that's done. So after you've selected this, you then go down to submit request, and you enter your email twice, and then click the submit button, and you'll get a notice here that your data is being processed, or there's something wrong with your data, you've forgotten something, or so forth, and you'll have to go back and make changes. Then you'll be sent two emails. The first email that your data is being processed, and the second email is when your data is ready. It will contain a link, and you've got 5 days in which to download your file. So now I'm going to go back to AccuTrans, and I'm going to switch into this work area. And okay, here's another piece of the ice fields, and I'll select the top view, and you can see that I used the polygon selection and came around to pick out the map. So now I'm going to go to work area 1. Now once you've got your zip file, you just take and unzip it to your hard drive, and then you go and in AccuTrans you've got several ways of reading it. We could go to the Open As or the Open DEM as menu items, and these work like a recent read file list. And if I went to Open DEM as and then go to GeoGratis, and I clicked on it, and if I had previously read a GeoGratis file, AccuTrans would open to the folder that had that file. So it's a quicker way to find out where you are in the file. Otherwise, I could just go to Open and go to the directory I'm in. I already happen to be in the right directory. And then all I have to do is go to here and select GeoGratis, and then all my CSV files show up. And I've got a cold, so excuse the cough. You get very informative names: CDEM, DEM points, and then numbers. So it's not too informative, so you'll want to rename them to something else. Now I'm going to select Revelstoke, Lambert, CSV, click Open, and there's our terrain. Everything's done. It's nearly ready to go. Now I'll go to the Tools 1, Adjust Object menu. You will see that we're a long ways away from the origin, and these are our heights. We go from 1,349 meters up to 1,944 meters. And so the first thing we want to do so that they display right in light wave is I'll take and center the object around the origin and set the lowest Z value at 0 by clicking this button. Okay, so that's ready to go. If I wanted to scale the model, I could just enter scale values in here, click scale, and the model would be scaled. Now the unit of measurement in AccuTrans is a unitless one, so it is whatever it was that come in on the file. Now the CSV file used meters, and Lightwave uses meters, so no scaling is required to go out. I could put on this calculate scale button, bring this up. I could select an axis, put the new size I want on here, and hit calculate and get a scale factor. Another way of getting scale factors is click on units, and I can convert between import and export units from different sizes and add a second scaling factor if I need it. So that's done. So now I have my object, and now you might wonder, are the surface normals facing the right direction, or do I have to flip them? Well, I have by default AccuTrans does double-sided rendering, but I have it on set for one-sided now. If I take and click on the top button, okay, we're looking down on the terrain, and if I took and I rotated it, you can see, oh, it disappears. So they're actually, and if I do go to double-sided rendering, okay, both sides are visible. And so it's ready to go to a Lightwave file. Now if I needed to align them, I could just do align start, and we could see they're all white. We're looking at the visible side of the triangle, and if I rotated, the bottom is red showing that's the invisible side. And so if I come up, and if I just clicked, I'm set on flip all, so if I just click on one of the white triangles, they'll all turn red, and to get them back again, I just have to click once more and they're back. So we're all aligned properly to go out. And I'll turn that mode off. Now, I'm going to select the top view, and now you can see that the object isn't square to the sides of the view window, and that's because it went into that conformal conic projection. And if I wanted to rotate them so that they were parallel, I could just go to the edit menu, click adjust, and this is the center point on this mesh, and I'll click rotate, and I want 1, and I could just click on the scroll button, and I could go down here and rotate on the axis to straighten it out, or I could go up here and enter 20, and now it looks nice and square. I could go turn parallel mode on, view mode, and yeah, it looks nice and parallel, and then just click OK, and so now I've got it all squared up to go to Lightwave. Now to save a file, you go to File, several ways of saving. The longest method is Save with Options, and it comes up and it gives you all the options for outputting to the file. Now, right now it's set to Kirkathea output, and you can see I've got 2 pages here, one with output and one with Kirkathea on, with other settings you have. Now if I go and select, now if you notice here we've got that many, these are universal flags for all the file formats, and as you change file formats, they change. So now if I go and I switch to, for Lightwave, huge objects, you can see that page disappeared because there's no extra page for Lightwave, and I've got more choices here of what I want to do. If I want the various things to be output to the file, I check them. If I don't want them to go, I uncheck them. And if there isn't something in the file, in the mesh, it doesn't matter whether we're checked here or not. And then I just do, and I click Save. It comes up with the file I want to save in. This is the model of the axes that I had showing up earlier. I'll just go and click Save, and it's now saved. And so now if I went to open again, and before I do that, I'm going to go down here and pick another work area. I'll click open and switch to Lightwave. There's the model we just saved. Bring that in, and there's our Lightwave mesh. Now the model I saved here was done with the Lambert conformal projection. Now I also have, open this back up, I also brought it in as the Geographic Projection. Now, and it comes in and it looks the same as the other one, but it's square to the world. Now, what happens is there's a lot of fancy calculations are done for the to get that Lambert conversion. But I have in AccuTrans a very simple conversion, which brings the which converts the latitude and longitude in degrees into meters. And instead of being a long ways away from the origin, you can see that it's right down at the origin on at the bottom left-hand corner, and the heights are the same because the same ones were written to the file. So AccuTrans will bring in both of them, but using the Lambert ones will give you the highest accuracy. So that concludes this tutorial. Goodbye.